Hello, thank you for being with us today. We enjoyed hearing so much with you yesterday. Let's introduce ourselves today.
Hi, everyone. Nice to be here for another episode of the JavaScript Days. Hi, Julia. Hi, Dina.
Hey, Natalia. Yeah, it's great
We
being
don't have
here
the
today.
slides.
Sorry, Dina?
The slide.
Yeah,
Oh, yeah, there we go.
There you go. So let's quickly introduce ourselves. My name is Natalia Venditto. I'm a product owner for JavaScript end-to-end on Microsoft Azure, obviously. And I'm here with Julia.
Yeah, thanks, Natalia. Hi, everyone. Yeah, my name is Julia. I also work at Microsoft as a cloud advocate in the JavaScript team. I work alongside Natalia and Dina and some amazing people that you will be interacting with on the chat today. So over to you, Dina.
Hi, I'm a senior content developer working on JavaScript on Azure. I love helping developers use the Azure cloud. I also work with Natalia and Julia on a regular basis, and let's see what we have today.
Yeah, but first of all, let's see where we are all connecting from. So you can see we're connecting from different locations, all the way from Redmond, Washington, where Dina is at, to Barcelona, where I'm at in Spain, and Nairobi, Kenya, where Julia is connecting from. That's spanning 11 time zones. And we would love to know, where are you tuning in from? Let us know in the chat. We would love to know what you're working on, what's your role title, the most fun project you're working on, even if it's your work project or your side project. And we also want to learn from you what you want to learn from us in the JavaScript Azure community.
Yeah. Sounds great. Sounds great. And yeah, as Natalia said, we would really, really love to have a very interactive session today. So please say hi on the chat. Introduce yourself. And then for those who were there yesterday, we had day one of this event and we learned so much yesterday. So if you had some key takeaways, please also drop them on the chat. Would really love to understand what was your key takeaway, what did you really enjoy so much about yesterday. And yeah, as we continue with the sessions, drop your questions. We do have a few experts on the live chat today, so if you have any questions at any given time, just drop them on the chat and we'll be able to respond to them. So with that, let's move on to the next slide. We have some good news. Our Cloud Skills Challenge is still ongoing. And Dina, Natalia, would you imagine that we already have 500 developers who have joined the Cloud Skills Challenge? So I was
Wow.
really impressed, and I know that people are learning out there. So if you have not yet joined the Cloud Skills Challenge, scan the QR code on your screen, and a link will also be dropped on the chat. So you'll find several Learn modules that will help you just put into practice all the content we'll be talking about today and some of what we covered yesterday. So when you have a few minutes in your day, just join this challenge and just get to do a module or two. We have 7 more days remaining, so definitely get on board, join the 500 that are already learning with us. So with that, I will pass it to Dina, who's going to talk to us a little bit about the Contoso project.
Yeah, sorry, Julia, for moving the slide over, but I'm super impressed about having 500 developers already doing that challenge. Is amazing.
Yeah.
Yeah,
Awesome.
Dina.
Yesterday, we demonstrated how to use AI with developer tools such as Copilot to implement services with LangChain and content moderation to deliver the best of both worlds, best developer experience and top-notch end user satisfaction. So I wonder what we're going to learn today.
Wow. What we're going to learn today? We're going to have everybody build it with us, right, Dina?
Yes. We're going to talk about Contoso again. We're going to talk about our fictitious property management site that's enterprise grade. It views houses, condos, and cabins. You'll probably use such a site to book a vacation. This example, enterprise architecture, includes all the source code, deployment infrastructure, and testing you would need to build on top of Azure. Each composable package is available for you to learn and extend. Come build with us on top of Contoso Real Estate.
Right.
Right. Fantastic. So I know that we've talked so much about the Contoso real estate project. I've personally had a chance to look at the code. So if you haven't yet, also scan the code that is on your screen. This will take you directly to the repository where you'll find the code, you'll find everything you need to get it up and running. It's also set up to run in a container, so you can definitely start the project in a code space. That way, in a few minutes, give it about 10 minutes, if I'm not mistaken, just to have everything up and running, because it's a really, really bulky project. It has, as Natalia mentioned, it has so many components using so many different services. So once you open it in a code space, give it some time, allow it to set up, and then just get started. Just looking at the code, just deploy some of the solutions, and then we'll be really happy to see some of your contributions coming into this specific project. Now, something to note is that once you open your code space, the moment you're done with the project, do ensure that you stop the code space just to avoid depleting your free quota. So as soon as you're done with this project, as we said, it's really bulky. So just to spare the quota that you have for your code space offering, ensure that you stop it immediately you're done. So let's look at some of the tools that you would need to have this project up and running. It's a very short list, and I'm sure that almost all of you have everything that is on the screen. So you would need Visual Studio Code just to probably run the solution. You also need to have a GitHub account. I am almost sure that all of you have that. For GitHub Codespaces, if you've not utilized your free offering, every month you do get 60 hours of free Codespaces. And for students who've joined us, you actually get up to 90 hours of free Codespaces. So use that offering, get to have this pre-configured developer environment running on the cloud that will really have everything you need for this project pre-installed for you. And then as an optional tool, you can choose to use GitHub Copilot. That way you can just write your code faster and get to enjoy some Copilot goodness as you build. So I'm not sure we're going to use Azure today, but if you want to deploy some of these solutions, you would need to have an Azure account, since it uses different solutions such as container apps, static web apps, Azure OpenAI, and I know that Natalia will talk more about that in the next slide.
Sure. So this is the diagram or the map of this application. When we show it, sometimes we know that developers are like, oh, wow, that's a lot of services, a lot of components. how am I going to be able to build that in one go? Well, you can, like Julia just mentioned, is code spaces ready, is also dev containers ready. So you can do it locally in your computer as well, if you have the necessary dependencies, such as Docker, for example. And we use this as our flagship application. It's an architecture reference for JavaScript enterprise applications on cloud-native Azure. So it's 8 scenarios that we have been implementing, integrating, and delivering over a long period of time, more than 1 year, for you to learn best practices to build with JavaScript, with serverless, like we said, cloud native, and modern delivery patterns for scalable, robust, and extensible applications on the cloud. And yesterday we discussed the support bot chatbot that is integrated in the portal. It's an Azure OpenAI plus LangChain application built with the RAG pattern. And if you go back and see the session yesterday, you're going to have all the information on how to check out that repo, because it's a module linked to the Contoso app that you can build standalone, or you can build as part of this enterprise larger application. And but we also have a lot of other scenarios, some of which we're going to be discussing today, because this is a federated vertical micro frontend split. So what that means is it has 3 different frontend UIs, and it has also some services that are containerized and connected or integrated via serverless APIs run on Azure Functions. And today we will discuss Azure Static Web Apps as a hosting service with integrated capabilities that simplify building GraphQL APIs and querying data with configuration only. You will be amazed. We will also discuss the possibility of querying data from other providers by showcasing our integration between Vercel and Azure Cosmos DB for Next.js applications. And we will also have expert advice from Playwright ambassadors and the Playwright team to do the end-to-end testing for these composable type of architectures, for these massive scale applications, and how to do it, again, with best practices in mind and the right way. So yeah, on to the sessions. Yeah, here's the agenda with Dina.
Well, as Natalia said, the first session, we're going to talk about the new JavaScript SDK from Cosmos DB and how it integrates easily with Vercel now. And then the second session, we're going to talk about how to use GraphQL APIs without actually developing the server, which is very nice for front-end developers who have to do that back-end work. And then if we can go to the next slide. In the third session, we are going to talk about notifications with Socket.io, and they really show a great example of how to plug it into the Contoso app. So you're going to see direct relationships between those notifications and that real estate website. And then, as Natalia said, the Playwright stuff. Now, I actually watched this one ahead of time, and I learned thinking in Playwright now. I've got it going, and I have some code to fix. So next slide.
Right. So yeah, I think, Dina, you've given us like a small sneak peek into what to expect, but I'm honestly excited for the 4 sessions we'll have. So I think at this point, we'll just all get off the screens, and then we'll have our first presenter just take us through all the goodness with JavaScript and Azure Cosmos DB. So I think we'll have now Sajeeth take it away.
Absolutely. Don't forget to chat with me there. Bye.
Hey everyone, thanks for joining and welcome you to all another session of Azure Developers JavaScript Days. I'm super excited to join you all. Before I kickstart, I'm Sajeetharan, working as a product manager in the Azure Cosmos DB team, focusing on making Cosmos DB as the go-to database for developers, driving features to make developer experience better on Azure Cosmos DB, and also working on integrations with other products. Please feel free to post your questions in the chat. We will be answering them as we go along. Today, I'm excited to talk about the JavaScript ecosystem on Azure Cosmos DB and take you through a few end-to-end demos to showcase the latest features on the JavaScript SDK. This is what the agenda looked like. For those who are very new to Cosmos DB, I will be sharing a glimpse about Azure Cosmos DB to get started. Then I will dive into ways to interact with Azure Cosmos DB with a focus on JavaScript SDK. We'll jump into talk about the new features that we have recently added to the JavaScript v4 SDK that was announced in September last year. I also have an end-to-end demo to showcase the usage of JavaScript SDK as well as some of the features that we recently added to improve the troubleshooting from the developer experience. Lastly, I wanted to talk about the recent integration that we have worked with Vercel. At Azure Cosmos DB, we always wanted to meet the developers where they're at. So with the recent integration of Azure Cosmos DB and Vercel, developers can deploy their applications with Azure Cosmos DB as a backend to Vercel without any cost. Let's get started. This is one slide that showcases the capabilities of Azure Cosmos DB. Let's analyze why Azure Cosmos DB a bit through a developer lens. First of all, you might know Azure Cosmos DB is a fully managed service that is no-brainer, and it can be very attractive for developers. Availability is something that helps the developers so that they can focus on the application and less focus on all the plumbing and the infrastructure. We are providing 5 nines of SLA with the capability to replicate your data with a single click. Azure Cosmos DB's currency is request units, as you might know, or we call throughput. Developers can set the throughput as they require to get the benefit of guaranteed latency. Azure Cosmos DB supports multiple data models, including documents, key value graph, and the column family. So it's interesting to a lot of developers with existing applications or platform. There are multiple supported open source APIs as well as multiple supported development languages. With this support, developers will be able to go from infrastructure as a service to a platform as a service with no or minimal code changes. The other thing from a developer standpoint, Cosmos DB being schema agnostic, which is very attractive, and again some of the service fundamentals such as global distribution, multi-master, which helps the developers out of the box to replicate the data and handle the concurrency. And some of the features such as scale, consistency, indexing are provided out of the box without any manual work needed by the developer. Azure Cosmos DB supports configuration at different modes. You can have provision throughput, or you can go with auto scale if you have a spiky workloads, or even serverless if you're building POCs, and so on. We care about security, so data security on Azure Cosmos DB supports native AAD integration as well as with customer managed key support. You can bring your own key, which helps a lot of security scenarios. Also, other thing is that NoSQL APIs supports for querying items using the structured query language syntax, which provides a way to query JSON objects that developers heavily use on web applications. Also, the capability that we have, such as stored procedures, user functions, triggers, which is really a big plus for developers to build some of the new developer scenarios in their applications. Some of the recently announced features on Azure Cosmos DB, such as materialized views, time travel feature, which is the change feed, and also on the analytical store, GraphQL support and vector search on Azure Cosmos DB will make the Cosmos DB as a choice for developers to build their cloud native and modern AI apps. I hope that sets the context for this session with the introduction to Azure Cosmos DB through developer lens. Some of the common use cases of Azure Cosmos DB are that if you want to build applications that scale with demand and provide low latency guarantees with high availability and geo-replication, and also considering the developer productivity features, Cosmos DB is the answer. Given that I talked about the capabilities of Azure Cosmos DB, and I also wanted to highlight the customers who are leveraging Azure Cosmos DB at a scale. These applications are mission-critical applications with millions of users accessing at the same time across the world. One of the relevant examples in the current state of software industry is that ChatGPT uses Azure Cosmos DB. I just wanted to highlight that again, Azure Cosmos DB is a database for next-gen apps. With that, let me jump into the core part of this session. As I mentioned earlier, we wanted to make developers' life better, especially web developers. If you're wondering how to interact with Azure Cosmos DB, firstly, we provide REST endpoints for both data and control plane operations. Using the data plane REST endpoint, developers can work with database accounts and perform any operations. So the way you access is by using the account endpoint, which you can grab from Azure portal against the Cosmos DB account. The next one is the control plane operations REST endpoint, where you can use that to perform any of the control plane operations, such as creating the resource, deleting the resource, controlling the throughput, and so on. Next is the developer-friendly SDKs. We have built our SDKs for a wide variety of languages, starting with .NET, Java, JavaScript, Python, and Go. If you're a developer who prefers ORMs like Entity Framework, we provide that support as well. Since Azure Cosmos DB is a multi-model database with multiple APIs, especially the open sourced ones such as Mongo and Cassandra, when it comes to drivers, we do not want to reinvent the wheel. Developers can leverage the existing drivers. For example, if you're a JavaScript developer using Mongo API on Azure Cosmos DB, you can use Mongo client driver and perform all the operations on how you would do that on native MongoDB. Similarly, for Cassandra, Kremlin, and Table APIs, we provide the same support as well. Recently, we added a new feature. This is for front-end or Jamstack developers, the ability to generate GraphQL endpoints on Azure Cosmos DB to make the web developer experience better through Data API Builder, which is an experience to generate GraphQL endpoints on top of Azure Cosmos DB with few commands. This is a very cool feature, as you can build GraphQL endpoint and consume it on any platform, device, or any language. These are different ways to interact with Azure Cosmos DB. Since we are at Azure JavaScript Days conference, let's dive into JavaScript SDK in detail. JavaScript SDK for Azure Cosmos DB has evolved over a period of years. We have 4 different versions of JavaScript SDK. The most stable version is the version 3.0, and we recently launched the version v4.0 with a lot of capabilities back in September last year. Let me dive into some of the capabilities that we added recently. First one is the client request diagnostics. If you're a developer who wants to have insights about the operations that you perform, to provide enhanced insights into client operations, each of the Cosmos DB SDK requests that you make contains a response object which has details about the diagnostics, including the metadata lookups, retries, endpoints contacted, and the request and response stats like payload size and duration. The next feature is that if you're new to Azure Cosmos DB, you might already know that Azure Cosmos DB distributes the data across logical and physical partitions based on your partition keys to support horizontal scaling. By using hierarchical partition keys, you can configure up to 3 levels of hierarchy for your partition keys to further optimize data distribution and support the high level of scaling. We added this feature to JavaScript SDK so that you can perform all operations with hierarchical partition keys enabled. This feature lets you to build SaaS applications or multi-tenant applications, as you don't have to worry about the logical partition size, as well as you have the ability to query using a multi-level partition key support with the operations that you make on. The next feature is that change feed. Change feed is one of the cool features that developers love to have. For example, if you want to fetch all the changes that happened on a particular document, JavaScript v4 SDK supports that. Choosing to fetch the change on an entire container using a specific feed range or a partition key is supported, and then you can perform various starting points. For example, you can do with continuation tokens, or you can start the feed from the beginning, or you can start at the current time or a specific time as well. So these are natively supported with the JavaScript SDK and widely adopted in case of migration scenarios, as well as in order to real-time notification application. We also support the ability to set the priority level for your request. This ensures that low priority requests are throttled before the high priority requests when the throughput limits are reached. So this is a handy feature. You just need to configure the throughput level with the options that are provided. We have also enabled index metrics support through the JavaScript SDK v4, which makes whenever you execute a query, the response object will have details about the indexes that you used for that particular operation. These are set of the features that we recently added, which add more value to customers to build awesome things on Azure Cosmos DB. You can follow this blog, which has details about each of these individual features as well as set of samples on how you would use it on Azure Cosmos DB using the JavaScript SDK. With that, I wanted to jump into the demo part of it. Let's see some of these capabilities in action through a demo. You can follow the demo along with me by navigating to this URL and clone the repo. And with a single command, you should be able to start the application. This application was built by Wasim Cheham. He's the cloud developer advocate in the JavaScript team. So this application is built with Next.js and React and uses Azure Cosmos DB SDK to create simple web experience that allows users to store their OpenAI ChatGPT sessions in Azure Cosmos DB. In this case, we are leveraging NoSQL API or the core API to store the chats on Azure Cosmos DB. Going with the trend of RAG pattern, basically this application retrieves based on the prompt that you send, and then a user can store those sessions. I will not dive into details on the RAG pattern as there was a separate session on how to build the capability on a web application using OpenAI. I will mainly focus on the JavaScript SDK capabilities in this application. Let me jump into the demo. So the sample is already available in public. You can just navigate to this particular URL. Basically, set of instructions are given in the repo. So this uses the sample data set that we already have in the Contoso real estate, which was put up by the JavaScript dev advocate team. So you can get started by creating a new Cosmos DB NoSQL API account, and then we are using the hierarchical partition key feature that I already demonstrated for storing the users and the session. And then we are leveraging the GitHub auth in order to authenticate the user. We need to have certain environment variables created. You can see the Cosmos DB account endpoint, the key, and then the GitHub auth URL, the GitHub ID and the secret. And finally, the RAG API URL. In this case, we are leveraging the existing sample that was built by the dev team of JavaScript. And finally, you need to execute this npm command in order to run the application. Then with a single command, you can see the application running locally. Let me show a quick demo on, since I have already cloned this application, you can just navigate and do a npm run dev. This should spin up the application in local. Parallelly, let me show the Cosmos DB instance that I already have, which has certain data that has been already inserted. But you can see like we are using the hierarchical partition key user ID, and then we also have a session ID. In this case, I'm using 2-level hierarchical partition key, but certainly you can go up to 3-level. So whenever you issue a query, you need to make sure that you need to use the user ID and the session ID so that the throughput or the RU charges will be less for the point read queries, as you might already know. Let me go back and see if the application has already started. It looks like it has already started. Let me navigate to localhost 3000. Let me sign in with the GitHub ID with the GitHub authentication that we have implemented. So the capabilities of this application is that user can prompt certain questions which uses the RAG pattern to retrieve the information which is already stored. I'm not going to touch upon the part because that has been already explained in the other session. So in this case, I'm going to showcase the capabilities of JavaScript SDK that we are using to enable this application features, right? For example, in this case, at the bottom, you see the request duration and then the operation query. This particular capability is the diagnostic request that I explained earlier. So it contains the information about the query operation that you made, as well as what is the time it took to fetch the details from the database. The overall duration, as well as this is on the server side, and what is the SDK version that you're leveraging. And it contains more level details, but if you want to fetch that, you can just print the diagnostic objects. And the next capability is that the sidebar that you see, which stores the sessions of that particular user. Basically, it uses the session ID as well as the user ID, which I showed in the Cosmos DB account. Basically, we are querying using the hierarchical partition key. So these two features are highlighted in this particular demo. And yeah, let me show the code on how to use the JavaScript SDK in order to implement this. As you might see in the package JSON, we are already leveraging Cosmos DB SDK, which is version 4.0, and it contains several environment variables as I went through earlier. And the other important part is that the lib.js file, which imports the Azure Cosmos package, and then you can see the database that we are interacting, which is chat history, and then the container ID is the session. We also retrieve the endpoint using the endpoint environment variable as well as the key, and then you could see some of the operations that we perform. For example, yeah, we are retrieving the sessions from the database, and then you can see the items being retrieved using the fetch all operations, and then some of the CRUD operations like deleting the session item, and then listing the session as well as inserting using the hierarchical partition key. The other feature that I explained earlier is the diagnostics. So whenever you issue a request, you can see that there is a response which consists of items as well as diagnostic object. So diagnostic object will have contains about the metadata, lookup, as well as the request time, as well as the response time, and also certain other aspects that you would need to have it in your application in order to troubleshoot. In case of hierarchical partition key, you can see that we are pushing two levels of hierarchical partition key. One is the user ID and the session ID, and then you are able to store that particular data using those hierarchical partition key, and you can use the same keys to retrieve the data from the Cosmos DB as well. So this is very easy to consume, and to create an application like this to perform some of the CRUD operations using JavaScript SDK. JavaScript SDK also supports bulk, batch as well. So if you're using any of the bulk operations, certainly you can leverage the JavaScript SDK. And if you want to perform change feed for the real-time notifications, you can use it as well. So I just wanted to summarize the capabilities that we have added in this application. Let me jump into the second part of the session, which is the Vercel integration with Azure Cosmos DB. By integrating Azure Cosmos DB with Vercel, we aim to streamline the development process, making it more efficient and productive for developers. With this integration, developers can leverage the strength of both platforms, combining the serverless deployment with the capabilities of Azure Cosmos DB at free of cost. Before diving into the demo, let's take a moment to understand the significance of Next.js and Vercel for developers. Next.js and Vercel have emerged as the indispensable tools for modern web developers and web development. Vercel is a front-end cloud, which means a place to go for everything you need as a web developer to deploy the application without ever having to leave the Vercel dashboard. Vercel helps the developers to deploy their websites instantly without any configuration and management. Vercel does it on the edge so that your website is so fast and it can be accessed by anyone across the world. And it does seamlessly. While Next.js is a React framework that provides a robust foundation for building scalable and high-performance web applications. It includes first-class support for TypeScript and React while offering easy solutions for some of the most common requirements in the modern application development, which gives the developers best developer experience with all the features that they would need. Our goal with this integration is to empower developers with seamless access to powerful capabilities of Azure Cosmos DB within the Vercel platform. Developers can leverage this integration in two modes. One is directly by using the integration, which is available in the Vercel marketplace. We also have published a template for developers to get started with JavaScript SDK as well as Azure Cosmos DB. In this experience, you can see when you commit the code to GitHub, which can be fetched as Vercel projects, and then you should be able to integrate with Cosmos DB, where the integration marketplace provided by Vercel by searching for Cosmos DB, and then you should be able to connect with Cosmos DB. This integration is basically to set the connection string of Cosmos DB so that you would be able to use the JavaScript SDK to connect to Cosmos DB and perform all the operations that application needs. So this is kind of the end-to-end experience. Let me show a quick demo of the integration. So this is how the experience of the integration would look like. You can search for the existing integration by using the search bar. Otherwise, you can navigate to databases and then you can see the Cosmos DB integration. When you open up this integration, you can see some of the details on the integration. And then if you're new to Cosmos DB or the JavaScript SDK, we also have a pre-built template. You can get started with this template, which is a to-do app. In this case, I just wanted to deploy the same application which I showed earlier, the chat application using the rack pattern, which stores the session of that particular user. Let me navigate to Vercel and add integration. So once you click on add integration, you can see the GitHub user account. If you want to give actions to a specific project, so in this case, let me select the rack Cosmos DB Next.js project, which I already have on GitHub. You can click on install, which will basically pop up the installation page. You can sign in using the Azure Cosmos DB credentials. For example, if you have a subscription already, if you have a Cosmos DB account existing in a particular subscription, which that particular application uses. In my case, it is in the Cosmos DB general use subscription. And the Cosmos DB account in this chat app is the Contoso. Let me search for the Contoso account. So we have all the settings in place. You can see the directory subscription and which Cosmos DB account that you want to connect with this particular application, and the project in this case is rack Cosmos DB Next.js. Once you click on integrate, what happens is that it goes and complete the installation by setting the connection string of the Cosmos DB, so that you can see the integration is already done. If you want to uninstall or remove the integration, you can go ahead and remove the integration. Let me go to my application and see if I can access the application and use as it is. So if I go to dashboard and then open up the deployment, and if I access this particular application, since the deployment is completed, yeah, you can see the same experience deployed to Vercel. So that's the power of Azure Cosmos DB with Vercel integration. As a web developer, you are able to use Cosmos DB by creating a free Cosmos DB account, and then you're able to leverage the Next.js to build your application and deploy it to Vercel instantly using the Vercel deployment and the Cosmos DB integration. The integration sets the Cosmos DB connection string, as you could see, as the environment variable. So this is a whole integration experience. I hope you are able to get the whole concept of the Vercel integration with Cosmos DB. Let me quickly show the next capability of this integration, which is the template. The whole concept of introducing template is that in order to make developers' life better, especially if you're new to JavaScript SDK as well as Cosmos DB, this particular template enables the developers to understand the best practices of the JavaScript SDK and the ability to perform some of the basic operations using the JavaScript SDK. So the instructions are already published in this particular GitHub repo. It's already under the Azure repo. You can go ahead and experiment with it. And then there is a sample end URL which is deployed to Vercel as well. So in this case, you can navigate to Vercel under the templates. You can search for the Azure Cosmos DB Next.js starter. And if you click on deploy, it automatically fetches the repo, and then you can see this is part of the Azure Cosmos DB. You could just provide a name for the repo saying JavaScript-based and then create a repo. So this template would fetch the information from the Azure starter template that I showed earlier, and then you can add the integration as well, which would set the connection string for the Cosmos DB account. In this case, I'm connecting to the Cosmos DB account, where I have the data to be inserted. In this case, let me select my subscription ID and select the Cosmos DB account, which is Cosmos demo. And once you click on integration, it will set the connection string. And as part of this to-do application, we do have to create certain collections. So this is automatically done by the template itself. You can see the Cosmos DB container name and the Cosmos DB data name. So for example, if you want to have your own collection name, you can just give the names and then click on deploy. So once you deploy, you're good to go. You can see the application is getting deployed, and you would be able to see the template deployed to Vercel. And if you want to build your own applications, you can access the boilerplate and then modify the template according to the way you need. Yeah, cool. We have deployed the template, and then you can go to dashboard. So the application is live, and if you want to add a new true item to do JavaScript days session, you can see that the item is getting created using the JavaScript SDK. And if you want to say delete this item, yeah. So basically we are able to perform the CRUD operations using the JavaScript SDK through the Vercel template that is already published. So that's the capability of Vercel template. We will be publishing more templates, including the rack pattern sample that I showed in the deployment scenario. With that, I have come to the end of my session. So just to summarize, if you want to get started with the JavaScript SDK and want to see the latest capabilities that we added to V4 SDK, you can navigate to ak.ms Cosmos DB.js and see the announcement on the V4 SDK. To read more about the Vercel integration and the template, you can get started with ak.ms Vercel integration. And finally, the repository that I demonstrated is available in this URL. You can start building your own repo and deploy as a template, as well as deploy to Vercel to see the. And finally, the demo repository is available in this URL. You can create your own templates if you're interested in building new templates for Cosmos DB, and reach out to us. And if you want to deploy your application to Vercel, you can follow the same demo that I showed earlier. With that, I would like to summarize some of the key points. If you're new to Cosmos DB, you can create free Try Cosmos DB account using the Try Azure Cosmos DB by navigating to ak.ms Try Azure Cosmos DB. You should be able to create all type of APIs accounts, which is completely free. And then if you want to understand some of the best practices, we do have the Microsoft Learn module where you can learn about different concepts and SDKs and developer experience on Azure Cosmos DB. Finally, if you want to build your skills and do a certification, you can just use the Microsoft Learn platform. With that, I have come to the end of my session. Thanks for the opportunity. It's been wonderful talking to you about the JavaScript SDK and Vercel integration. Yeah, looking forward to meet you all in another session. Thanks, everyone.
Everybody, and thanks so much for joining us today to learn a little bit more about Azure Static Web Apps. I'm Stacy Cashmore. I'm a tech explorer DevOps at Omniplan, a financial software company based in Amsterdam in the Netherlands. I've been programming for far too many years. And since 2020, I am shocked and honored to be able to call myself a Microsoft MVP in developer technologies. And with me today, we have Thomas.
Hi, Stacy. My name is Thomas. I'm a product manager on the Static Web Apps team, and I've been on the team for the past 2 years. We've been working on shipping a bunch of great features that really help with the productivity and let us building applications very quickly and with that global distribution. And so, yeah, I think I'm super excited for the demo that we have cooked up for everyone today.
Absolutely. Why don't we bring up the app and we have kind of a starting point. I've been playing around with the To-Do app because everybody does demos in To-Do apps these days. So I've written this in Vue, which is not a language that I'm experienced in, but I fancied a bit of a challenge. And we have a To-Do app where we can enter the to-dos. So we can do our introduction, we can show the app, and we can delete our to-dos. Now, this is all running inside the browser at the moment, which is, it works. It does what it's supposed to do. But I'd really like to be able to save my to-dos so I can come back to it later. Because right now, if we hit F5, it's all gone. Now, normally at this point, I would start writing my Azure functions and connect them up to my Cosmos DB database in order to access everything. But Thomas is going to show us a way better way of doing this.
Yep, exactly. I'm going to show how we can use database connections, a feature of Static Web Apps, in order to really easily have API access to our database without having to write a bunch of boilerplate CRUD code in order to have access to that. So what we have right now, and I think this is the database that you created for us for this demo, Stacy, is just a list of to-dos in our database. So right now we have a Cosmos DB database. We have a list of to-do items, and then here, we have just some sample data. If I refresh that right now, I think we only have a single to-do. And here, if I zoom in a little bit just to make it easier to see, every to-do has an ID along with an accompanying user ID, and then we have a label for the to-do, and then a completion status under complete. And so what we're going to do is we are going to use database connections in order to provide an API access, in this case, a GraphQL API access to this database. So we're going to be able to make this CRUD level access via that database connections GraphQL API. Now, what I'm going to do is, in order to get started with this, I'll bring up our code. And right now, we basically have our to-do list code, right? This is what we were working with. This is our to-do list.view, making a bunch of different calls to create to-dos, update the to-dos. And what we're going to do is we're actually going to be using the SWA CLI in order to emulate the database connections that we get when we deploy our Azure Static Web Apps. Now,
get more awesome functionality from the SWA CLI.
Yep, absolutely, absolutely. And so I already have the SWA CLI installed, but if you don't have it, make sure to install it so that you can emulate this experience locally. And what I'm going to do is I'm going to call the SWA DB init command. Now, the DB init command will just scaffold the configuration that's needed for this, the data source, and also a couple of the additional configurations that are needed for this feature. So if you see, we went ahead and created, you'll see that there was 2 configuration files that were created within this SWA DB connections folder. So let's take a look at that. First, we have the staticwebapp.database.config.json file. Now, this file is really to establish the connection with the database. In here, you'll see that we have the option to put in a connection string. And what I'll be doing here is instead of directly indicating my connection string, which I could do, but in order to avoid leaking any of my secrets, I'll be referring to an environment variable. And you know what? I will also go ahead and establish that environment variable in my terminal. Now, of course, I've leaked my secret, but don't worry, I'll have deleted that by the time this demo goes live. And
at least it's not in your code.
Yeah, no, exactly. I won't be backing up anything to Git or committing anything into my repository. In this case, I can indicate that I have a container, which was to-do items, and then we have the database, which was demo. Now, one of the more interesting parts of this configuration file is here towards the bottom. We have the entities object. In the entities object, we can opt in to exposing any of our database entities to database connections, right? So by default, none of them get exposed. You really have to opt in for security purposes, and this allows you to have that fine-grained control over what you do want to expose. In this case, I'm exposing the to-do items, which matches the specific source of to-do items in my Cosmos DB database. And I'm just going to give any user, all CRUD access for this. And here's actually where most of the heavy lifting happens, is where we indicate which entities we do want to expose. And then, probably the last thing for this is, in order for me to show you the full potential of database connections, I'm going to switch the mode to development mode. This will give me the chance to show you a little bit more of the development aspect and the developer experience that we do get out of the box with database connections. So this was just the configuration file. You may have noticed that there's another file, this .gql file. It's really just there to indicate the schema of our database. So as you know, Cosmos DB as a NoSQL database, we can't necessarily extract the schema from the Cosmos DB database. So we do need to indicate that here in the schema file. This matches exactly what was in the Cosmos DB. But yes, for the other databases that database connections support, this isn't needed. But for the case of Cosmos DB, we do have to indicate that, since it's a no Cosmos, NoSQL database.
Makes sense.
Yeah. Now, what we have with this is we now have the database connections configured. What we can then do is run our swastart command. So let me see if I still have that up here. Yeah, we're going to be using swastart. This is going to be what's going to allow us to emulate the static web app experience. We are going to point our app dev server URL to the localhost 8080, which is already running here. And I'm going to indicate the data API location, right? And so this is the location of this folder here. In this case, it's just /swatdb connections, and I can press start. And what this will do is it's basically going to provide us this fully emulated experience, and it's going to spin up the database connections that are required in order to have that experience emulated locally.
You've got to love the SWA CLI, the amount of things that you can do with this, from development to deployment to initializing your project. Such a fantastic tool.
Yep, absolutely. And so now let me go ahead and check it out. Let's see if we have this working. Okay, so we have the application working here, and we have these requests being proxied to our view server. And I think what we'll want to focus on now is taking a look at what we get out of the box in terms of GraphQL APIs with our database. And so if I've configured everything correctly at this point, I should be able to refresh the page. And since I'm in development mode, I get this really beautiful IDE where I can test this GraphQL API. So in the operations, I can go ahead and test some of these, right? So you can imagine I have a get. And in the get, I can specify, hey, I want to get my to-do items, get specific attributes of the to-do items. And this is the power of GraphQL. You can indicate what you want the response to return. So in this case, if I did want the user ID, I can just edit that, that query. And as you can imagine, we have a list of either queries where we can get to-do items or unique to-do items, or also mutations. And so we have access to all of these APIs out of the box with database connections. And now we can actually call them from our code.
And it's cool, really cool that we have GraphQL here. We don't actually have a GraphQL database. We have a Cosmos DB SQL API, but we can use GraphQL in order to access it, in order to get that control that we need when running the app.
Exactly. And we didn't need to build out a whole GraphQL server and have specific resolvers resolving a query to a specific Cosmos DB field. Instead, we just use database connections, and we already have that GraphQL API that's already ready for us to use in our application. And that's actually really easy for us to do at this point. And I want to show you how we can go ahead and call these from our application if you're ready, Stacy.
Awesome. Yes, let's go.
Okay, excellent, excellent. Let's do it. I'm going to pull back up my VS Code. I already have my database connections configured. Everything is running great. And now all that I have to do is call this set of APIs from this to-do list.view application. Now, what I've done is I've added I've added just a couple functions that will be making these API calls. And so let's step into the list, which is a simple get. Let's dissect this. I'm just going to give us a little bit more space to see. And let's dissect what this function does. First of all, we're defining a query. This is the GraphQL query that is going to allow us to indicate what specific attributes of our items we want to receive. And you'll actually notice that this should look familiar because I just showed you something very similar in here where we're making a query to get the to-do items and receiving the items and indicating which attributes we want back. So we start off by defining this query. And then, of course, we're going to be making a fetch request to the specific /data API /GraphQL endpoint. Now, /data API is by convention. This is the sort of the subpath that we've dedicated within static web apps in order to handle the database connections feature. And in this case, we're accessing /GraphQL. So this is the endpoint we're going to be calling. Just due to how the GraphQL protocol works, we are making a post request and passing the query through our body. And after that, what we have is our response.json, where we can have access within the result to the to-do items and then accessing the items. And
nice. So that would be the data API. That's the same as the .auth, the / API that we used to have previously.
Yeah, exactly.
So that's all that same convention-based URLs, which is why the Svar CLI can actually do this so well for us. And the last one that I just really want to touch on, the GraphQL endpoint that we have there, that is the same name that was used in the configuration file. So you have control over that. Is that correct?
Yes, you actually have eyes of a lynx. That is a good catch. Yes, absolutely. This is configurable. If you do want to specify the specific GraphQL path, you can indicate that here. And so in this case, I just left it as is. But if ever you wanted to change that, you can change that definitely. Yeah.
Awesome. That's really cool.
Yeah. And so now that we have this list function, what we can do is we can call it from anywhere in our application. And so what I'll do is within my view, when my view component gets created, I'll actually call my list function in order to set the to-dos to retrieve those that are in my database and then return that and display that to our user. And so if we load back up our application, we head over to localhost 4280 and we refresh the page. There we go. We already have this item, which was in our database. So if I show you the network call and refresh the page, we are making a GraphQL call and we are receiving this specific item specifically from our database. And so if I refresh here, once again, this is this specific item, show list from database that we have here. There we go. We just got our get working.
So easy that would be a whole deployment and other stuff that you need to do in order to get your Azure functions working there with everything you've got to do for all the SQL integration. And yeah, this is just a few lines of code. It's fantastic.
Yeah, exactly. And so, hey, we've done it with our get or our query, and we can also do this with our mutations, right? And so I showed you just the list to start, but I also have added a function to update where we're calling the GraphQL mutation. And then we are taking in the specific to-do ID along with the new data. And we have our specific mutation indicated here where we can pass along the ID along with the new data. And then we just package that up. We package that up in the body of our request alongside the query and the variables that are to be injected within this query, right? So the ID is mapping to the ID, the partition key value mapping here, and the item mapping here. And then we will be able to call the update. And similarly, we do this with a create, where we can have a mutation to create new to-do items, passing along the variables and then making a post request. And then the same thing with the delete, right? I mean, they're all pretty similar. Once you have an update, you basically have a delete. Then once you have a create, you basically have an update. And so what we can do now is actually call these from our database.
And an important one for people to remember there, you mentioned it before because of the convention for GraphQL. We're using post commands here, so we're not using get, delete, put, and post.
That's correct.
Everything is a post request here.
That's correct. And we're actually using just fetch, right? We're keeping things super bare bones. But if we wanted to, we could be using a GraphQL client, which would probably make a lot of this easier. But I just wanted to make it as simple as possible and not require any additional libraries to make any of these calls. But yes, that's correct. This is how the GraphQL server expects these calls to come in. Everything is coming in as a post. And then the query is the one that contains whether it's a query or a mutation, and the specific attributes that we want to receive, along with the variables that we're getting. So yes, absolutely, totally correct. These are always HTTP post functions or requests. And yeah, this is how we make those GraphQL calls.
Okay, let's throw them into the code and get this working.
Yes, exactly. Okay, so I'm going to just start us off from here. Let's start with the add to do. Here within the add to do, we are creating our to do item. I'm just starting with some random strings for my ID and my user ID, getting the information for my label along with the completion status. And what we were previously doing solely in the front end in memory, we are now going to be doing within by using this create function, right? So we're going to be invoking the create function and then updating our state variables, and might as well go ahead and update our toggle completed. So I'm going to jump over to the toggle completed, just simply calling the this.update, passing along the ID of the to-do along with the new value of the to-do. And finally, if we go over to the remove to do, what we'll be doing is instead of solely updating the front end variable, we are going to be updating the front end variable, but also making that GraphQL request call to delete the item. And so at this point, what we can do is return over to our database, and we can go ahead and add a to do. We can see that this is firing off a GraphQL request, and so that was our query, our mutation to create a new to do. We can update to do, which will also send over a GraphQL request, and then verify in the database that these are all happening in real time. And so if I show you the database and I refresh it, what we now have is all of those new to-dos that we created in our application, in our database. Our create is working, our update is working, and our delete is working as well. And so that was me just deleting that last one. And so yeah, exactly. We've shown the list from our database. We've added a to-do. We've verified in the database. And so at this point, we have our full CRUD access working. Everything is, we're storing the state fully in our Cosmos DB database with our create, read, updates, and deletes.
And with just a few lines of code.
Yeah,
I say
exactly.
that's got to make, for this type of application, that has got to make access so much simpler than it was before. And it gets rid of the issue of the cold start, of course. I know that if my blog site, if nobody's accessed it for 30 minutes, the first person that goes there, they have to wait 10, 15 seconds for that function to warm up before they get the data back. Whereas this is just snappy. It's just there.
Yep, exactly. And so this was just really, we've just peeled the first layer of this onion, but we have a lot more functionality that happens under the scenes. We can add authentication and authorization. And then I want to show you how we can also deploy this application very quickly as well and connect it with our database. And so if you're ready, Stacy, I think we should go ahead and do that now.
I'm ready. Let's add some authentication. I like it when my to-do list disappear, but I prefer it if I'm the one that's like finishing them and cleaning it up.
Excellent. Sounds good. Let's do that. And all right. So now that we have our application running with CRUD access to our database, what we'll want to do is add a little bit of authorization. We don't want
everybody to be able to do everything.
Yeah, exactly. We probably don't want that. And so what I propose that we do is what we're going to add is the ability to have specific roles for our users. And depending on this role, our users will be able to have different levels of access to our data. And so just to keep it simple, I'm thinking logged in users will have edit access, but logged out users, users that haven't logged in yet, they will only have read access. How does that sound?
That sounds like a great start to get going, to show what we can do here.
Okay, yeah, sounds good. So let me pull up the code, and great, I'm already in the configuration file. I'll start off in this database connections configuration file. And what we can do is we can head on over to the permissions for our to-do items. And as you can imagine, I came ready, and so I already have this commented out in the code. What we're going to do is we're going to change this array of permissions. And the first permission within this array, what we have is we have the star, which is all of the potential actions. Well, they're all going to be available to authenticated users. Now, this role, and I know, Stacy, you're super familiar with this, but this is one of the 2 predefined static web apps roles. Every logged in user has the authenticated role, and every logged out user has the anonymous role. And so by using these sort of preset roles, we can go ahead and ensure that someone is logged in order to have edit access, and we'll just leave read access for folks that are logged out.
Using that easy authentication again.
Yeah,
Perfect.
exactly.
And looking at this, you can also make this really fine-grained if you want to. For the different sources, you can have different roles. For the different actions, you can have different roles. You can make this as simple or complex as you need for your use case.
Yeah, absolutely, absolutely. And we can change these permissions for every different entity in our database, and so we do have like as much of granularity that we can get with this RBAC. And of course, we're just going to use anonymous and authenticated, but we can have a lot more roles, and that's all coming with that easy auth and role management that we get with static web apps out of the box. So now the one thing is I will have to restart my database connections in order to refresh this configuration file. We're working on that so that we have hot reload, but that's something that's in progress. And so for now, we'll go ahead and restart it. And the other thing that we'll do is within our code, as you know, we'll have access to when a user is logged in, we can access the /auth/me endpoint in order to have access to the client principal, which contains information about the logged in user. And so when the to-do list component will get mounted, we're actually going to call that in order to have access to that data if ever we wanted to use it when we're creating a to-do and referring to the specific user ID later on. So yeah, I am adding this to our function. And now if I go
hey, look at that, you're logged in.
Refresh the page. So I know for sure that we are getting the information. I am not sure that I am logged in. Let me go ahead and try to make an edit. I'm going to try to make an edit. And yes, you're right. I am logged in. Perfect. And so with this login, I now have access to the read, the update, the delete. And it just so happened that right before this, I logged in through the static web apps, the Swasialized emulated login. I added my username. These were the 2 default user roles, and I went ahead and logged in. And so with this login, I have access to this edit experience. But I can also be logged out. And so if I did go ahead and try logging out, what we would see is when I try to make an update, what we'll actually notice is that we get a response from GraphQL indicating that the current user is not authorized to access this resource. And so if we were actually to refresh the page, we'll notice that any of the mutations that I tried to make, so new to do, well, they're not getting persisted in the database, and I'm getting errors in my my application. Now I haven't necessarily added handling of these errors, but you'll see that we do have that RBAC coming into play and preventing logged out users from having edit access. They still have read access, but they don't necessarily have edit access. We really do need to be logged in to have access to that.
Which is, it is a fantastic first step. And of course, when doing this properly, we'd also use a user ID when we're fetching the list of to-dos. So in your GraphQL query, you can say, hey, only get the ones for this user. And we can make this like a proper app.
Yeah, absolutely. Absolutely. And I think that the to-do list, you're probably often looking for specific to-dos for a specific user. But let's say this was more for a line of business application or something where you're using more roles and it's shared across users. You're very likely to benefit from this RBAC, where a specific role within your different users has access to all of the same permissions. And so
absolutely,
yeah, absolutely. Yeah, there's definitely a lot of flexibility there. And I think that the last very interesting step is just how easy it is to deploy all of this. And so what I've done is I've already committed these changes, and I went ahead and pushed to my GitHub repository. So I have a GitHub repository here for this specific demo. Of course, starting off from your starting point, Stacy. But what I've done is I've created a static web app resource with this repository. Now, in this static web app resource, what we can do is we can head on over to the database connection tab. And in here, all we have to do at this point is link our existing database. Now, the reason for this is that we've sort of used the convention folder name with SWADB connections. By default, as build time, that was picked up by the database, the static web apps image, and it was packaged and included in the deployment. And now all of those configurations are available. And so all that we have to do at this point is go ahead and select our database. And that's actually going to go ahead and configure the connection string for it. And at this point, what we can do is head on over to our resource, open up our to-do list. And if I go ahead and show you the network tab and then refresh the page, what you'll notice is that we are getting the GraphQL. We do have that level of authentication that we have added. And so this is me as a logged in user. I have access to new to-dos, but any logged out user would essentially not have access to all that functionality because we've added that RBAC access, right? And so if we tried to edit with a logged out user, we'll see that we actually don't have access. And so our RBAC and our authentication is really taking its place and doing what it needs to do.
And that's it. We have a deployed app. It's working. I can't get over how easy it is to connect the database. It's when you're running through the tutorial in this, I think the biggest issue that I have in my mind is I try and overcomplicate it. It cannot be this easy. What have I missed? But I'm hoping that everybody's seen from this that no, it really is that easy. You really can get your data out that quickly so that your users can have better access.
Yeah, absolutely. And you know, when you think about it, we actually did a lot over the course of this 20-minute demo. We went from a front-end application to storing in a database to adding authentication, authorization, and then deploying that all within that span of time. And so I think that there's just immense functionality and productivity in this. And we're continuing to build this out and improve all of the different database types and their integrations. We're working with the Azure database teams in order to improve the functionality. And we're also working to improve the local development experience. And so there's actually a lot in store coming with this feature. It's been a blast working on this specific feature. And
I can imagine.
And, hey, yeah, exactly.
It's one of those ones that when you look at it when you're done, the value to developers is just obvious once it gets going.
Yeah, absolutely. And so what I do want to have a call out is as we wrap up, I do want to point to our docs. We've worked really hard to make it as easy as possible to get you from scratch to fully deployed full stack web application. And we have very specific tutorials for all the different database types, along with all of these code snippets. And so some of these code snippets that I showed you earlier and that we added to our code, you know, a lot of them we took it from our docs in order to make it as simple as possible to follow. So yes, I definitely think that if anybody wants to try this out, these are great resources. And during the preview of database connections, you know, this feature is actually free for any static web apps that you have. And so I think that there's just tremendous value in this feature. And, you know, we've seen the adoption, the feedback has been great, and we've just kept on iterating on it.
Yeah, I can imagine that. It's like I said, it's so easy to get started. No Azure functions, no cold start. Perfect. There's one last thing that I just wanted to say just before we finish off. Really important bit is that word preview. there are some bits in there that, we know still needs to be improved to make sure that you really can have even better control over your data than we have right now. It's in preview. It's constantly being updated, and I just can't wait to get using this.
Yeah, absolutely. And the other database types are Azure SQL, MySQL, and PostgreSQL. And so, like you were saying, some of them have a bit more functionality than others. Some of them also have the ability to have REST APIs. So I definitely think that it's worth checking out. I've had a bunch of fun working with those specific database PMs and dev teams in order to add all of this functionality. So yes, definitely. And we keep on iterating during this preview.
Okay, and I think on that note, we are about out of time. I would like to say thank you so much. That's such a fantastic demo. I love demos where you can just really show stuff happening in almost real time, getting it out there to really show how quickly you can do this. Thank you, everybody, for following on for this session. Thank you so much for joining us. And from me, Stacy Cashmore, goodbye. And from Thomas.
And from Thomas, goodbye. Thanks, everyone, for listening. And yeah, let's get building. Thanks, everyone.
Hello, web developers. This is Kevin, and I'm the product manager of Azure Web PubSub and Azure SignalR.
Hello, friends. This is Ken, and I'm the engineering manager of Azure Web PubSub and Azure SignalR.
So Ken, what are we talking about to the web developer community today?
Well, today we are going to talk about implementing real-time features on the web. More specifically, we are going to talk about open source library called Socket.io.
Oh, that's great, since the Socket.io is very popular with JavaScript developers. But Ken, you live and breathe real-time technologies. Can you help us understand what you mean by real-time?
Yeah, for web development, when we are talking about real-time, we are referring to the situation where the server sends messages as soon as something interesting to clients takes place.
Can you give us some concrete examples?
Yeah, sure. An example I'd like to use here is the auction website. When a visitor comes to a web page and explores the product listings, we want to show the latest prices. As you can imagine, the prices change very unpredictably. From a technical perspective, we need a way for the server to push data to clients.
The web largely works on a request and response model. The request comes from the client first before the response. If you are talking about a server pushing data proactively without the clients asking for it, I guess that's why we are talking about Socket.io library today.
Yeah, exactly. Over the years, there have been other solutions based on HTTP, like some pooling techniques, but now WebSocket API is well supported among major browsers. It is a better solution for real-time needs, but using plain WebSocket API can be challenging for large-scale applications. That's why developers have turned to libraries like Socket.io.
I know today we're going to build a real-time notification feature with Socket.io, but before we get into the hands-on demo, on a very high level, can you share with us why JavaScript developers favor Socket.io?
Yeah, sure. Yeah, we ran a developer survey last year and learned that developers love how intuitive the APIs are, which we are going to explore very soon, and how feature-rich the library is.
I'm just scrolling through Socket.io's website. It says it supports reconnection, acknowledgement, broadcast, and among others.
Yeah, broadcast is a feature that is often needed when building real-time web apps. It allows you to send messages to a group of users with just one API call.
I guess following your auction website example earlier, I can put users who are interested in a particular group and a particular product in a group. And whenever the price of that product changes, I only need to make one API call to send a message to everyone in that group.
Yeah, exactly. This is not something that is provided by plain WebSocket API, but is often needed for real-time app scenarios.
You are getting me really excited about a notification feature we are building today. So developers, if you're interested in learning more about the features and benefits about Socket.io, you can head over to its website. On it, you can also read about the results of the developer survey Ken just mentioned. But without further ado, Ken, shall we start building the demo?
Yeah, of course. Yeah, understanding business requirements is often a good place to start. Kevin, can you walk us through what we're building today?
Yeah, not a problem. Contoso Real Estate is an open source project that demonstrates how JavaScript developers can leverage Azure to build enterprise-grade applications. This is what the real estate listing site looks like. As you can see, you can browse through the apartment listings and make bookings. Now imagine during the holiday season when lots of people plan to travel and apartment listings are snatched up quickly. It would be very frustrating to a holiday goer when they proceed to checkout, only to realize that the listing they're interested in is no longer available. A better user experience would be to send them notifications about the availability of listings in real time as they take the time to decide.
Yeah, sure. Let's put the requirements on the screen and discuss them in detail.
Yeah, so there are two situations where we'd like to send notifications. First, when a user favorites a listing, we'd like to send a notification to everyone who's currently online, something like a user has a favorited listing. And second, when a user makes a booking but didn't complete the payment, we'd like to send a notification to everyone online as well.
Yeah, for this demo, this is great as people who are watching this video can easily see how the notifications are pushed from server.
Yeah, of course, in a real app, we need to carefully think about when to deliver notifications to whom and how to ensure a better user experience.
Yeah, now let's look at this slide and let me reiterate the user flow to develop a better understanding of what we are planning to achieve. Now, let's say this user favorites a listing. A message will be sent to the server, and then the server will send the notification to every online user. The message payload probably only needs to be the listing.
Yep, precisely. Thank you for taking the verbal description of requirements to something closer to implementation.
Kevin, yeah, let me just show you the results I've just get working. Yeah, I have two browser windows open. Each one represents a site visitor. It's the same app we just saw earlier. You see the difference here is that there is a bookmark icon. Let's say this user is interested in this listing and she favorites it. Now look, the other user sees a notification immediately. Notes that this user is not requesting anything from the server, but she still receives a message from the server. It is possible because of the persistent connections Socket.io maintain for us. Now, let's do it again.
Oh, that's really cool. Now I can see how Socket.io can complement the typical fetch APIs. So can we talk about how we are going to implement these features?
If you remember from earlier that we mentioned that the web is based on a request and response model. The request comes from a client first. Without a request, the server cannot respond. To deliver the notifications proactively from server to clients, we need something like this. And Socket.io takes a step further. It allows the client and the server to communicate freely, which means any party on either side can send messages to the other. This kind of communication pattern is often described as bidirectional.
That's really cool. That means I can continue using GET and POST requests for some interactions and use Socket.io to handle the real-time needs.
Yeah. Besides providing the real-time capabilities, Socket.io's API fits nicely in the event paradigm web developers are familiar with. Let me show you. On the right side is the client-side code. We first import the library and create a Socket.io client object. The object is the entry point to all the capabilities the library offers. Just like how we can register an event handler with a DOM element in the browser, we can do the same thing with the Socket.io client object.
Yeah, I guess here with this line, it achieves what this line achieves is that when there's an event called server message coming from the connection, this callback will be executed in the browser.
Yeah, exactly. When the callback is executed, the data sent from the server will be passed in as arguments. Here we don't do anything interesting. We simply log the payload to the console. That's the receiving a message from the server. Remember that Socket.io is bidirectional, and let me show you how to send a message from the client. Different from HTTP request is low latency. The message here is called emit and accessed through the object we just created. The first argument is the name of the event. You can name it whatever fits your app, and the rest is the data you want to send to the server.
How would you use these client-side APIs for the notification feature?
Yeah, to receive a notification when some other users favorites a listing, yeah, maybe we can name the event notify favorite and access the listing from the arguments passed in. Yeah, when a client favorites a listing, yeah, we will emit an event, maybe call it send favorite, and provide a listing title as the payload.
Gotcha. What about the server? What's the server-side code?
Yeah, well, it's not that different. Yeah, after importing the server-side library, yeah, we create a socket.io server object, and this server listens for a connection event. This is one of the built-in events of socket.io. Yeah, whenever a connection is established with a connection with a client, a callback will be executed with the socket object that identifies a particular client.
I guess here what this line does is that whenever a client connects with this socket.io server, the server will send an event, and the payload is this.
Yeah, what this does is that when a client emits an event, this callback will be executed on the server.
Yes, the client side and server side code is quite similar, if not the same.
Yeah, that's why developers like socket.io. Once you become familiar with one side of the APIs, the other side is pretty much the same.
So Ken, again, how would you apply the server side APIs to our notification feature?
Yeah, since we only have limited time today, and we'd like to keep the demo simple to highlight the core features of the socket.io. Yeah, whenever a client establishes a connection with the server, we listen for the send favorite event from the client. When the event comes, we simply send a message to every online user by emitting a notify favorite with the listing. Yeah, remember this is the event name we just listen on the client side. We are going to break it down into 3 steps. First, we establish a connection between server and client. Then we send a favorite event when client favorites a listing. And finally, server will broadcast the favorite event to all clients, and the client will render it in UI.
That sounds like a plan to me.
Yeah, as shown on the socket.io website, first we need to install the library. Yeah, once it's installed, we create a new socket.io server with a few lines of code. Here we listen to a connection event, which will be triggered whenever a client connects to the server. Here we don't do anything interesting. Let's simply log the socket ID to the console.
So that's the server side finished?
Yeah, that's it. Since for the step 1, we only want to test out the connection, we will leave the actual implementation in step 2.
Let's move on to the client side then.
Yeah, same as before, we need to install the client library first. Here I create a real-time service. We initialize a socket.io client object in this constructor and inject the real-time service for the other parts of the app to use. Let's run the app and see if the connection is made.
I see the server logs out the ID of the client.
If you open the debug console in the browser, indeed we see a WebSocket connection is made. Okay, next, when a user performs a favorite action, we need to let the server know. Let's locate the real-time service we just created earlier and add a method called broadcast favorite notification. This method wraps around the socket.io emit API and emits a send favorite event, and the payload is the title of the listing. On the server side, we need to listen to the send favorite event and log it out. And Kevin, where do you think we should put the code?
Since we need to register event listeners, we need to do it as soon as possible. I guess we should do the registration when the connection is made between the server and the client.
Let's put it here. Shall we run it?
Let's do it.
As you can see, server first logs out the socket ID like before, and it logs out the send favorite event with the listing title. Now that we have confirmed that the bidirectional connection is established, one thing I want to highlight here is that the connection is persistent. Either party can send data through the connection at any time. No need to take turns.
Now that the server can receive an event when a user favors a listing, it's time for the server to broadcast this action to everyone online.
Sure. On the server side, we just need to call the same emit function to broadcast the notify favorite event to all connected clients. On client side, we listen to this notify favorite event and use this notify function to show this information in a snack bar component. Now that the UI is done, let's test it out.
I'm going to volunteer to test out the app. If I click the bookmark icon on the left screen, which represents a site visitor, I should see the notification on the right screen, which represents another site visitor. Works as expected. Nice job, Ken.
Yeah, what we have is one socket.io server handling all clients. In production apps, it is rare that one socket.io server is enough. Yeah, often developers need to scale it out to multiple socket.io servers. Yeah, setting up infrastructure of multiple socket.io servers and allowing broadcasting messages to work properly can be challenging and time-consuming.
When we ran the developer survey last year, this challenge of using socket.io library was ranked the highest. And this is an area where we thought Azure could bring value to developers. With the input from socket.io's developers, we introduced native support for socket.io on Azure.
Yeah, how does this native support mean for socket.io developers?
Well, it means developers continue using socket.io APIs they know and love, and which you demonstrated earlier, and let Azure handle scaling out.
Okay. Let me show you how it works in action.
Ken, we only have a few minutes left. Do you really think there's enough time for this?
Yeah, that's plenty of time. Yeah, we just need to make a few code changes. First, we need to create an Azure Web PubSub resource, which I've done already ahead of time. On the client side, the clients will be connected to a cloud service on Azure, and we just need to change the endpoint the clients connect to. And on the server side, we just need to install the Azure Service SDK and make a few lines of code change to configure the Azure Service. And that's it. Yeah, these are all the changes we need to make. And now let's run the app and see it in action. Yeah, well, nothing interesting on the UI has happened. The interesting change took place behind the scenes. Let's look at the network panel, and you can see the connection is now made with the Azure service instead of a local socket.io server.
I see. Since the client is connected to an Azure service, it relieves the pressure on the application server. The heavy load is now taken care of by the service. So Ken, I mentioned that Azure can handle the scaling out. What kind of scalability are we talking about here?
Yeah, we're talking about up to 1 million current connections and more.
Wow, that's quite impressive. You know, what's more important to me is that achieving this kind of scale, as a socket.io developer, I only need to make a few lines of code change, as we demonstrated earlier. So that's it. If you are a socket.io developer and would like to learn more about how you can leverage the new Azure capability, you can check out the link below. And if you're new to socket.io, we recommend you having a look at its documentation. And also you can check out the step-by-step tutorial of how to build a code streaming app where one person writes code and other people on the internet can watch every keystroke in real time.
Thank you for watching. Yeah, we hope you find this session useful and go building real-time apps with socket.io.
Hello everyone, welcome to JavaScript Days. Our talk is called Playwright in Action, from setup to best practices. And with me is Stefan. Stefan, do you want to introduce yourself?
Hello Max, hello audience. I'm Stefan. I'm based in Berlin, like Max is, and I'm doing Playwright end-to-end stuff now for multiple years. I'm also a Playwright ambassador, and I'm convinced that Playwright is a stellar tool to end-to-end test and cover all your applications. And I'm super excited to talk about all the goodness that you, Max, and team are shipping these days.
Thank you so much, Stefan. And I'm Max. I'm working in the Playwright team since almost 3 years. And yes, we are both based in Berlin. So let's get started. So for all of you who don't know yet, Playwright, what is it? Playwright is reliable end-to-end testing for modern web apps. So nowadays, if you are working on a web application, right, you are adding a lot of features, but at some point you're adding like some of the features and you might break some of the features which you shipped half a year ago. And to prevent that from happening, you do testing, right? But there are two kinds of testing, either manual testing, which means you go through all of the features of your web application by hand before release. But that's really time consuming, right, Stefan?
100%. And especially when you have complex applications, for example, you have to cover 10, 12, 15 cases, even developing the things and clicking all the different edge cases through it. Automation can be a huge help to speed up development, but also keep the quality high.
Exactly. So back in short story, back in the days when I was working at some other company, we were working on a huge web application, and then we decided we want to release, and it took us sometimes, I believe, 2 or 3 days in order to just manually test through all the features. Yes. But,
and then find a bug fix and start all over again, right? It's
yes,
just
exactly.
too much time.
Exactly. And the solution for that is automated testing, and this is what Playwright offers. So automated testing means everything what you can do with your mouse or your keyboard, Playwright can do in an API programmatic matter. So yes, let's go over some of the features and highlights. So Playwright is a browser automation framework for any browser. So you can automate Chromium-based browsers like Microsoft Edge, Google Chrome, or Firefox. And Firefox. And you can also automate like WebKit. WebKit is the foundation for Safari. We work on any common platform. So this means like Linux, like Ubuntu and Debian, Windows, obviously, and macOS. And we have one API. So ideally, you write your test once and it passes in all of the 3 browser engines, or it fails if your web application has a bug. So yes, and we have full isolation. So this is also a huge difference to other end-to-end testing frameworks. So one test can never break some other test, only if you change something inside the state of your web application. And we are fast because like we don't need to relaunch all the browsers over and over again. We have browser context. And we have powerful tooling. We will go into that more detail later on, which brings you a nice developer experience. And last but not least, we have multi-language. Here on the right side, you see our GitHub repository. So Playwright is fully open source. As of today, we have almost 60,000 stars on GitHub and 3,000 forks. And yes. So regarding multi-language, Playwright is available on TypeScript and JavaScript. This is what we're going to focus today. And we are also available in Python, .NET, and Java. So yes, we said powerful tooling. Our most powerful tooling is the Visual Studio Code extension. This is the best and easiest way of getting started with Playwright. It enables you to create a new project, write tests, generate tests, run them and debug them from Visual Studio Code, our most beloved code editor nowadays. Here on the right side, you see the extension with almost 500,000 downloads, and this is what we're going to use. Yes, so this was VS Code extension. Let's start with one of the fundamentals about like locating elements. And locating elements is essential to understand for Playwright because it's like different to how other tools are solving it. And Stefan, maybe you can explain them the difference of what a locator is and why a locator is better than just executing some JavaScript or so.
Yeah, so when I started using Playwright, I had to figure out, first of all, you have to familiarize yourself with what UI testing or end-to-end testing is, right? Most of the time, it's pretty much just finding an element, right, and doing something with it, and then waiting for something else, right? In Playwright, the foundation for all of these are these locators. And now for a little bit, Playwright and you and team brought in these get by locators. And these are pretty much like a blueprint, like a definition of an element that is eventually maybe in the DOM. So when you call, for example, like it's written there in the first line, locator equals page get by role button, it is pretty much just defining that you want to locate this element. And then you combine your locators with actions or assertions, which we will have a look at later, to kind of figure out if your web application is doing what it's supposed to. And then you can see some Playwright magic happening, and we will cover that a little bit later in the demo.
Awesome. So yes, that were locators. And let's get started with our demo. We will look at locators in a bit again. So immediately inside code. And let me move to Visual Studio Code.
So how do we get started, Max, from our most beloved editor?
So yes, here, Playwright Task for VS Code. This is our extension. I got it installed. And what I have open here is a folder. And the folder has nothing inside. And the easiest way of getting started is by saying install Playwright. Install Playwright is a command we expose in Visual Studio Code, and you can invoke commands based on the operating system with Shift Command and P. And let's just call it. And this asks you already like the most important question, right? The project you want to work on, in which browser engine do you want to test it, right? We support 3 browser engines. We want to test it in all because we want to cover all of our users. And let's just stick with the other defaults. Note also here the GitHub Actions question, which was asked, right? GitHub Actions nowadays is one of the most common CI providers. So if you want to run something on each push inside your GitHub repository, this is the right tool to use. We will go into some demo later as well. So yes.
So what was happening now in the background? I see the terminal popped up, even though we're in VS Code. What was happening?
So essentially what we did was we created a project, right? It was asking for some questions. And then in the background, this command was invoked. And this command is an internal command, but it's essentially just a wrapper around creating some files, which we have here on the left side, and installing Playwright and the browsers and on Linux the dependencies, yes.
The normal NPM dance, right?
Yes.
What files did we get now?
So here, the first file which we got was like the GitHub workflow. We will take a look at it later on. But the most important file is here the test directory with the example spec.ts. And here the normal NPM files, package log, and package.json, and some Playwright config. Let's close the terminal so we will have a little bit more space. And here we essentially see already 2 tests. And let's go over it. So a test in Playwright is essentially just a function call, and it might look familiar to you. Because like a lot of JavaScript test runners have this way of defining a test, right? By calling like this test function. And the first argument is like the test title. So in this case, we have 2 tests, has title here, and get started link. And I said before, everything what you can do with your browser, you can do with Playwright. So the first thing we are going to do is we want to go to some website, right? In this case, we will go to playwright.dev. And later on, we want to make sure that the title has a specific, that the page has a specific title. And this expect might also look familiar to you, Stefan. Have you used it before? Like,
For sure. When I started using Playwright, I felt immediately at home, right? Like you mentioned, this is very common syntax from libraries like unit testing libraries like Jest or other frameworks that are very familiar in the JavaScript ecosystem. But what surprised me initially was a little bit that because we're doing normal JavaScript here, right? This code looks very, very synchronous, but there are a lot of asynchronous and awaits happening, right? So what is actually going on here with our Playwright magic?
So what I did before, right? We like this was there before. This is like our special expect, how I call it. This is like the way how Playwright does expects, and these are like called web first assertions. And the huge difference to them compared to like normal expects, which you see in other test runners, like here, for example, is that Playwright in the background will retry them over and over again until a condition is met. In this case, that the page here has a specific title or the timeout is reached. And the timeout by default is, I believe, in this case, like 5 seconds. And before, like you might did something like this before. So you just did a normal expect without await. Note the difference here is in the keyword of await. And you were just passing the title to it, and then you were checking the to be value. So yes. So this is not recommended because this is not retrying, right? And retrying is what you want to do in order to avoid flakiness, because like imagine you have an online shop, for example, and some product detail page. And the product detail page in the URL has just an ID, for example. And when you try to navigate to this website, imagine it's a SPA, I believe, a single page application. It will need to do some background request to the web server to get the product title and the product name for this product, right? So we will navigate to it. It would in the background fetch the product title, and then later on it would just update the title. So if you would do this, in a lot of cases, it would just fail initially. You would have to add like a wage page for timeout and then some random value, but that's not something which is recommended, because imagine a network is slow on Thursdays, it might be 2,000 instead of 1,000, right? So never ever do this, always do this, because this retries over and over again.
Yeah, when I discovered how you folks envision UI testing, right? You always have to keep in mind what you want to do is you want to wait for an element and you want to reach the UI to have another state, right? You're just looking for UI state pretty much, right? And when you're dealing with expect, like we do here, you have to be aware, or honestly, it took me a while, but once I understood it, I was like, oh, this is so cool, right? Because line 7 just works. You don't have to care about implementation details. Similar to this is not only an assertion topic, right? If you go, for example, to line 18, where we click a button, this will also wait for this button to be there. So you don't have to manually query the DOM. It's like, oh, I need to wait for this network to happen and this URL to come. No, you should just care for this button to be there and click it. And this streamlines the entire topic of end-to-end testing so much that I don't have to have the headache of, oh, how do I figure out when something is there? Because Playwright does all this stuff for me. And I think it's very beautiful.
Absolutely, absolutely. So as you said, test like a user sees things instead of testing and waiting for the implementation detail, right? You could rethink this also, like what I just said means instead of like doing page.locator some XPath or some CSS selector, we instead say get by role of any link on the page with the text get started. This is what the user sees, right? A link for the user is most of the times some text which is getting underlined when he hovers over it, right? That's a link. And with the text getting started, and then we later on click it.
Yeah. 100%. When I first discovered these accessibility or UXC first locators, I honestly was a little bit skeptical because they are more verbose, right? I could just grab an ID or something, but very often depends on the relationship that you have with the development team. Maybe you're the developer yourself, right? But if you figure out, or if you base your end-to-end tests on UX and accessibility first, you will find so many issues that just make your application so much better. Because if you cannot find a user first or an accessibility first locator, well, then there's something to fix. And I think this is just another area or another way how end-to-end testing and Playwright just pushes for better web development. And I'm all game for these kind of things.
100%. So using these get by role selectors is essentially like accessibility testing, or partly accessibility testing as a drive-by while you write your end-to-end test.
Yeah. So we now have here two tests, right? They look fairly familiar, right? We're checking for a title, and then we're checking if a heading is visible. How can we run this?
Let me just run it. So what the Playwright extension offers you is this green triangle here. And you can just click it. Let me first remove this not recommended logic. And then let's just run it and see what happens. So what happens now in the background is that Playwright gets invoked for running this test, and each of these statements get evaluated. And then we will get some duration here, how long it took. And in this case, it passed. Nice. And it was green, but there was no browser. Where is the browser, Stefan? What happened to the browser?
Well, I think what you did here is you've run our two quick test cases in headless mode. I would love to see some action on screen, though. So how could I see what is actually happening?
All right. To see the browser in VS Code, let me move this a little bit here to the right. It's as easy as saying show browser. And it's here a checkbox inside the testing tab of VS Code. You will also see all your tests here in some kind of tree structure. So let me fold this back again, and let's run it. And what this gives us is the browser. And the browser were ended here and stayed open from the last test state. So in this case, we were just navigating to Playwright Dev, and then we were checking of the title. So essentially, we stayed on the same page, right? Quite boring. This test is a little bit more involved. So if you click on it, it will first go to Playwright Dev, click on the first getting started link, and then it will navigate to docs intro.
Yeah, I found this particularly helpful. So we now have 2 example tests, right, that have 2 or 3 instructions. But when you're dealing with an entire end-to-end flow, that includes probably hundreds of steps like clicking buttons, adding products, logging in, logging out, all these kind of things. It is so helpful to kind of follow along, see what's happening. But I think the real beauty of VS Code actually comes in when you start debugging things. How could we debug what is actually going on here right now?
Let's maybe let's try to debug this thing here maybe. Like I want to see what's going on. So debugging in VS Code with Playwright is very common to all the JavaScript developers out there because it's essentially reusing the normal JavaScript debugging. So we will just right click here and say debug, and this will start or initiate a normal debugging session in VS Code. So you have your variables here, you have your watch, you have your call stack, and it will give you a little bit more goodies. Like it will, for example, give you the goodie of when you hover over things here on the right side, it will select the elements on the left side. So as you can see, I'm hovering over this get by role selector on the right side, and on the left side of the screen, the getting started button is essentially selected, and a little bit down below there's the locator of the element.
This is so helpful, honestly, right? Because locating elements in a hefty web application, we're looking here right now at the Playwright docs, right? But sometimes you have hundreds of buttons, 50 products, and then figuring out, okay, what is my test actually looking for? I found myself just tabbing along the test pretty much most of the time, because this is where a lot of errors come from, that you're matching the wrong elements. And this is just a very nice goodie in the debug view.
100%. So we can just step over more things here, and we clicked on the element, we navigated, and here it's again highlighting, in this case, installation, the heading installation, because we are like here having an, let me make this, put me to the left side. So we are now here at the last step. We will awaiting the expect that it has a heading with the text installation, and it's highlighting it. And here it's another web first assertion, right? We previously didn't talk about it, but we have these assertions not only here on the page instance, we also have them here on the locator instances. So you have to be visible, to be enabled, to be disabled, and all these kind of assertions. So
and these are waiting, right? These are similar to the Playwright approach. Just describe your UI and wait for it.
Yes, exactly. So what about maybe extending this test a little bit more? Like we are saying here that a heading with installation is visible. Let me try to pick an element maybe.
Let's do it.
So another feature Playwright for VS Code here offers is this pick locator feature. You get it in the testing tab, and you can just click here, pick locator. And what this offers you is one part of our feature we call Playwright Code Gen. We'll go into the detailed code chain later on, but this locator picker here will, like, over all the elements you hover over, you will get a Playwright accessible for like a role-based selector, or we try to find the best selector for the specific element. Let's call it like that. And we are on the intro page, so let's maybe try to create, or let's try to get a selector for this PNPM tab. Let's just click on it. And in VS Code, we will have it right there. Let's move it over here.
This is the perfect flow when you're really in the nitty-gritty of debugging and writing your test code, right? You don't have to interrupt your session, first of all, and then you get the help to continue or adjust your tests right in your editor. And this just helps you to keep rolling, right? Without restarting everything and finding the same state again. And I'm using this pick locator all the time too.
Nice. So yeah, that's why we added it to VS Code. So you can immediately create locators of the, either like during your test run while you're debugging it, or also like afterwards when the browser is still open. So let's get out of this test run maybe and start writing our first tests.
Can I do that from VS Code too?
Yes, you can. So yes, obviously just copy a new file, call it example2, and then close it, remove all the stuff. And then you would have to do page dot something. But do you need to learn all these things, Stefan?
I think you have a solution at your fingertips for me to really get started with things that are not the Playwright docs. So what is the quickest way to get started?
So the easiest way of getting started is again here inside this testing tab. All the goodies are there, and it's called Record New. Record New, let's just click it and see what happens. So Record New will give you two things. First, in VS Code, it will give you a new file, in this case test-1 spec.ts, with some recording text inside. The Playwright CodeGen is recording. And on the left side, you will get, like before, a browser window. And the magic happens now when you start interacting with this browser window. So to which website should we go?
Let's stick with the Playwright docs and let's see how we can extend it.
All right. So I navigated to the Playwright Dev website, and inside VS Code here, it added a page go to automatically. But that's not a lot of magic yet, right? So let's maybe try to click on things. Where should we click on?
Let's click first of all on the headline, maybe, and then on the search, and then let's all just do the search. And let's search for locators.
Locators.
All right, let's click locators. And what could we look for? Do we just want to look for quick guide to see if we have the quick guide in there?
We could maybe let's add an assertion so that the quick guide is on the page. Maybe someone would remove it. Like, we always want to make sure that the quick guide is still there, right?
Can I add assertions here now too?
Yes, since like I believe 3 or 4 Playwright versions, like less than half a year ago, we added the capabilities of adding assertions. So here at the top, you can decide either between assert visibility, assert text, or assert value. So assert value would be for an input box or a text area, and assert text for just making sure that the text is on the page, or assert visibility that a specific text is inside this locator. In this case, I believe assert text is the right thing. So let's just do quick guide. And we want to make sure that assert that the element contains text quick guide. Let's apply that here. And here in VS Code, it created an expect statement with page locator quick guide to contain text quick guide. That's not super ideal. Let's maybe do the other way around. So we do assert visibility instead. What this will do, we will see it right here. It will add a different one. It will add expect page get by row heading, right? Much better with quick guide and to be visible.
Yeah, the first one, I think to be visible is good enough, right? Because we're checking if the text is on the page by looking for the name property, right? Yeah. Could we now change the name property to something more shorter?
Yes. So this starts the discussion of like, should you always use CodeGen to write your test? Absolutely. But on the other hand, you should always go over each line we generated, right? And try to either optimize it or just maybe think about if you can refactor it, make it a little bit more readable by either extracting variable names, etc. Maybe you're using some sort of patterns like the page object models, right? And you need to rewrite it for POMs afterwards. But let's maybe finish with CodeGen first. I believe we are done here. Let's maybe cancel.
Yeah.
So cancel will stop CodeGen, and let me make this full screen again, and let's refactor this. So we want to remove this. We want to remove that. And
why were we able to shorten the name property here? It was written direct linked or something. Why does that work?
So in this case, like we at Playwright in our CodeGen, we tried our best, right, to find a name property. But in this case, it kind of failed because like we use too much text, and very often you want to use much less text in order to actually assert the element you're looking for. Like imagine a perfect example is when you go to GitHub to a repository and you want to click on issues. I think by default it will give you issues with the issue number, but you're often not interested in that. So you can always remove the number and click just on issues. So
and name is substringing, right?
Yes. So by default, it's always contains.
Gotcha.
So let's move this to the right side again and try to execute it. Oof,
Magic.
That was fast.
But I think I'm demoing this quite a few times, right? And I think it's just beautiful that you can click around. You get now what do we have here? 6 lines of JavaScript that make a browser do stuff and tell me that things work. And this is really just a beautiful experience. So I can only second what you just said. CodeChat is the way to go, right? Even when you're debugging tests, just start recording. Playwright gives you the best it can do, then have another look and you can call it a day.
Yes,
pretty
absolutely.
much.
Absolutely. So Playwright is, or let's call it like end-to-end testing, is often also like underrated, because like for a lot of people, these kind of 5 lines, right? They will maybe like just look super minimal, but in reality, they are testing so many things, right? Even like this page navigation here, it's testing that your web server is correct, that the load balancer maybe is correct, that the CDN works properly, and then the search component for all these front-end people out there. It's not something which is just happening on our side, right? In this case, we are using Algolia. So we are testing a third-party service. We check that the integration works, that the authentication works. And for us, we do this, actually, we use something similar actually to always ensure that the search works for our users.
Yeah, 100%. And because the barrier is fairly low, right? Record the stuff and start covering a little bit of functionality in your web apps, whatever it might be. If I think, for example, you brought up third parties. Third parties are a wonderful reason to start end-to-end testing, because this is stuff that breaks without you doing anything, right? But if you have only 1, 2, 3, 5 end-to-end tests that cover your basic flows, your essential flows, that includes all the third parties that you have, that is beautiful. Another example that I know about, sometimes you have some third-party JavaScript that is just failing or blocking or breaking your page, right? Yeah. And you don't know about it. If you have end-to-end tests that really just check if the heading is rendered, if you have a blocking third-party JavaScript snippet in your head, you shouldn't, but very often, sometimes you must have it. End-to-end tests show you these kind of things. It just gives me as a developer the safety net that I need to ship good stuff. And I think that's why I'm a big fan.
100%. But now, Stefan, we wrote these end-to-end tests, in this case, like this test case locally, right? Let's maybe try to push it to GitHub and see how to execute it on the cloud. So that when you make more and more changes to your web application, which ideally you replace this with localhost and you spin up some environment in the cloud, but that this feature will keep working, right? So let's maybe push it to GitHub. So what I just did is like, here I navigated to the source control tab and I'm initializing this repository. And now it's basically the git init, and now I'm committing it and I'm calling it initial commit with all the files we just generated and wrote, and I'm publishing this branch, and I will publish it to GitHub, to the public repository. And this in the background, it will upload it to GitHub and so on. Let's maybe go to GitHub and look what is happening. So this is the repository. Let me zoom in a little bit. And here's the GitHub workflows file. So the GitHub workflows essentially is like the way how you give instructions to GitHub Actions. And let's look at it and see what you need to do in order to run your Playwright test on GitHub Actions.
Yeah, so it's I see we're doing things on main and master. This is just a default convention. What happens afterwards?
So GitHub Actions is a really easy way of doing things. So you just do, you want to check out, you want to have some node version, in this case 18, you want to have your npm dependencies, then something Playwright specific, you want to have your browsers with the dependencies, and then you already want to run the tests, right? npx Playwright test is essentially the command line version of running your tests, which we previously did in VS Code. And then something for later, we want to upload the artifacts, and the artifacts include some reporters. We will just look at it in a second. So these, yeah.
That would have been my next question. If I now run this stuff, right? For example, when I now run my end-to-end tests locally, I can follow up the browser, right? I can see something was off, the UI didn't reach the state that I'm looking for.
Yeah.
But when I run everything in the cloud, in a headless, cloudy, whatever world, how can I debug what is actually failing?
let me get a step back maybe. Let me just minimize this and go back in VS Code. So VS Code here on the testing tab not only offers show browser, it also offers show trace viewer. So trace viewer is a feature Playwright invented to essentially, let me maybe just use it and then I will talk about it. So I enable it here. I'm rerunning this Playwright test. Let's maybe use this default test for that. And it will also spin up a browser window. And yeah, so what is Playwright Trace Viewer? Playwright Trace Viewer on the left side will show you all the Playwright API calls. And for each of the API calls, it will give you a before and after and a during snapshot of the whole page. And this snapshot is not just an image or a video, it's a full DOM snapshot. So you can even pop it out and you can right click and inspect and look at all these kinds of HTML structures, CSS classes, and so on.
That is so cool. But it's we see way more things. What is there on top in the first row?
Sorry, what do you mean?
The images on top. What is there in the first row?
So yes, here on the left side, you see the actions. And for each action, you see at the top, timing-wise, where it was positioned. So the page go to, for example, it's right now highlighted. It took like 500 milliseconds. It's one of the longest things we did, right? And afterwards, we clicked, very short click, just 100 milliseconds. And this is what happened here. And on the right side, we check the visibility. So you can select here things, and these on the left side get updated and so on. But the most important stuff for debugging later on is here down below, these kind of information. So for each Playwright call, you get all the information which was passed to the call. You get console logs, you get errors, you see how the node console behaved, and you see, most interestingly, the network request. So in this case, for example, that the VS Code PNG had this specific headers and these specific response headers, and also this kind of body. Yes.
Yeah, I found the few things that I found the most helpful here is the dragging along in the top timeline view, because this kind of limits what I'm looking at. And then what I find myself using very often is the network panel, because in my day job, I work on JavaScript heavy applications. And even though my end-to-end tests are user first, very often the issue is somewhere else, right? And usually it sits somewhere in the network. And it could be a failed network request. It could be some authorization problem. And the help that I get in the trace viewer, that I can limit the network panel to a certain time frame, can see what UI or Playwright calls failed, and I only then have to look at 2, 3, 4, 5 requests. That is just tremendously helpful, because a long end-to-end session can take a minute, 2, with hundreds of calls, with hundreds of actions, but that I can drill down and have everything right in front of me is super helpful when debugging nasty stuff.
Absolutely. So imagine how it was like, let's say 10 years ago, 15 years ago, right? You had end-to-end tests, absolutely. They were hard to write, but much more, it was hard to debug, right? Let's imagine something was failing in JavaScript. There was some JavaScript console error, but you only had access to either a video or a screenshot. That doesn't help, right? But Playwright offers you here to see all the console logs, to see all the network requests, and then you can find out that your backend request was failing with 500, and it had this response trace ID, and you can map it to your map it to your applications request and find out that something in the backend was going wrong, right? But
this is so true, right? So the applications that I work on, it's like when you have your end-to-end test suite running for the first time, you're testing the application and the backend more often than every developer did before that. And currently, I'm working on a project, and we are just creating hundreds of orders, run hundreds of customers, and I occasionally see 500s, right? My tests fail because they run at scale. They run 10, 20, 15, 20 times per day. And thanks to the traces that I get from Playwright itself, I just can create a ticket and it's like, hey, this request was a 500. Even when I would have discovered this request by myself, by testing things out, a reload is quickly done, right? I'm not writing or copying the things right away. And trace files and the ability to kind of keep all this information just helped the teams that I'm working with just to keep and debug backend issues all the time because the network information is available. Beautiful.
Absolutely. So this is Playwright Trace Viewer, and you can get it locally by running your test. But most essentially, what we take a look now is when we go back to GitHub here in Google Chrome. Let me open this again. We see that here under the Actions tab, a test was failing.
Oh no.
Oh no, what did we do? And it did here the things we instructed before, right? Installing dependencies, browsers, and it was failing. Let's see why and what happened. Oh, there was something was failing. A heading with quick guide was visible. So here you already see some hints on why it was failing. Maybe you can make sense out of it, but for me, I cannot. I need more input. And for what else we offer you here is under the summary tab is we previously said we want to upload these reports, right? So let's just download the Playwright report.
Yep.
And I'm downloading it here right there. And I'm going back to VS Code. And let me go into the terminal. And what you can do here is like, first, let's try to copy it. I think it's like here, download. Nope. Let me move it here. Developer TMP, Azure JavaScript-based. Here we go. And we will delete this before, and we will extract it. So what we just did, we downloaded a zip file, we extracted it, and we can invoke now a cool special command. It's called npx playwright show report. And what this will give you is a report of the test we were just running on inside the cloud, inside Azure, and not inside Azure, inside GitHub Actions. And we see all the tests which we're running, right? We were running 9 tests. We were running 3 tests across 3 browsers, which means 9 different unique tests. And so we see this has title test, it has passed, get started link test, but there was this new test and it failed in Chromium, Firefox, and WebKit. Let's look at it.
Something is fishy here.
Something is fishy. Let's try to find out what's going on. So this here, the error is the same error as we saw inside our GitHub action logs. That's already helpful. And we see all the retries. Each of the retries behaved the same. But if we go now, if we go back here, we have this special button, and it's called like Open Trace or View Trace. And let's click it. And this will essentially open the trace viewer like we did previously locally, but from a trace which was created on the GitHub Actions run. And we can go over the statements here, and we see everything was working correctly, but this to be visible was failing. And we see all these informations, as said before, we see this line. And finally, I can see that this element, we have a typo here. It's called quick Gaudi instead of guide.
Didn't check before committing, huh?
We didn't, right? And so what you can now do, for example, is either the element has updated, right? You can click here on the locator tab and you can generate a new locator for this element, and you have it here and you can update it back in your source code, or you fix your web application, right? It could be either a bug in the end-to-end test or a bug in the web application.
For sure. Can people inspect traces when they don't have the Playwright binary somehow?
Yes. So what we just downloaded is the Playwright report. The Playwright report is what we call the HTML report. HTML report, let me go back, is this kind of view. So it contains all the details for each test, but they can also just download the trace file. And the actual trace file, you can go to trace.playwright.dev, and here you can just drop the trace file in, which is a zip file in the end. Let's just do this here. It's in the data directory. We have 3 for all these 3 browser runs. And if you drag and drop it here, you get the same experience essentially.
Yeah, I found myself in my team, we do that very often. We just collect the trace files, and then the team, because not everybody has the end-to-end setup naturally running, but everybody understands how to download a zip file and drop it into trace@playwright.dev. Yeah.
Yes. What else you can do is like we have it shown in the Playwright dev docs. Let me go here to Node, and if you go to Trace Viewer, we have this open, I think, viewing the trace, I believe here. Yeah, viewing remote traces option, right? And what you can do here is like trace.playwright.dev. This is the website we just went to. You can pass your trace location from some storage location like Azure's blob storage, and then it will fetch it in the background and it will give you the same experience. Like here, it's fetching it from demo playwright.dev.
Beautiful. So we have this kind of trace viewer available in the HTML report. We can access it via trace playwright.dev. Is there another area where this is popping up, this view?
Yes. So we all started inside VS Code, right? Let's go back to VS Code. But imagine you have some engineers who are either not used to VS Code or don't want to use VS Code. We try to give them a nice experience as well, and we try to add a specific need, the need for having watch mode. And we combine this inside a feature or a small product of ours, which we call UI mode. So let's just invoke Playwright UI mode, and you can do this with npx playwright test --UI. And what this gives you is, on the right side, it will give you almost the same as a trace viewer offers, like all the actions, in this case, none yet, and like all the snapshots and the timeline and the errors. But on the left side, it will give you a very similar experience of what VS Code offers you, right? A list of tests and a list of projects and a list of browsers, and you can filter them. So let's maybe just run them. Let's try to run the has title text and the passes in Chrome. And
this is all headless right now, right?
This is all headless right now, yes. So UI mode is a headless first application. So we give you the debugging experience inside this UI here, but the actual browser is running headless. So this means you can also go inside code spaces, for example, and run npx playwright test --UI-host with 0000, and you get the same experience. So you could run you can essentially develop Playwright tests inside the cloud completely without the browser locally, right? Except like opening UI mode, yes.
Nice. Yeah, I found myself, due to the watch mode, the way that I'm developing most of my complicated end-to-end tests is usually I start out in UI mode because it allows me to quickly iterate and rerun the tests depending on what I'm doing. But then if it gets really complicated or I'm hunting a bug, I'm definitely first on the VS Code front because of the debugging abilities, and then I'm just switching over. That's my approach these days.
Yes. So you can enable watch mode here, and you can make changes, and it will automatically rerun. All right, that's Playwright UI mode. Let's. I think that were most of the features Playwright has to offer. Let's jump back to the presentation.
Covered a lot of ground, Max.
Yes, we covered the VS Code experience. We covered trace viewer. We covered the pushing into GitHub. We covered UI mode, right? Yes. So that was our demo. Playwright is fully open source and free. So most of our downloads are on NPM nowadays. We crossed, I believe, the 5 million mark a few days ago. The screenshot is outdated. And on the right side, you see our GitHub stores, almost 60,000. And join our Playwright community on Discord. So for anything question related, join there. We have a huge community there. They write blog articles and create videos. And here on the left side, you see our videos section. And that's also where you see Stefan at the bottom, where he creates some awesome Playwright material. Here's some more resources. So Playwright, if you don't know yet, cross-browser web testing and automation framework. All the documentation is on Playwright Dev. We are open source. And if you have a feature request or a bug, just go to GitHub. So all our triaging happens on GitHub. We try to triage in less than 24 hours. And follow us on our socials on the right side, on X, Discord, or YouTube. And thank you very much and happy testing. Thank you all.
Wow. Amazing sessions for this second JavaScript day. Let's recap. Tina, welcome. Julia, we discovered how simple it is to integrate with Next.js applications deployed to Vercel, to query data from our best-in-class Cosmos DB databases that build amazing intelligent applications with, It always impresses me when I think that Cosmos DB handles the workloads of some of the most intensive artificial intelligence applications out there. We also learned how to use the built-in database connections functionality in Azure Static Web Apps to build configuration-based GraphQL clients and also APIs. And it's very straightforward. You don't need any boilerplate code. You just need configurations to get started and get going and productionize. We also learned how to make the best of pipelines and automation tools to integrate, provision, and deploy our JavaScript applications. We learned how to build real-time, event-based Azure native with Socket.io and Web PubSub applications that can send notifications to users in real time and talk to the database and have these give users this enhanced user experience to know what's going on in other parts of the applications with minimal effort on the developer side, the best developer experience. And we also finally had a masterclass on implementing best practices to test large-scale, performance-intensive, cloud-native applications or deployments with Playwright. So, wow, there was a lot to learn today. It was a full day. And yeah, I learned a lot. I don't know, you, Dina, Julia, I'm sure that you also, yeah.
Yeah, for sure. So I don't know. I know that all the sessions were incredible. So Natalia, I don't know if you have like a preferred session or just what was your best session today?
I love them all, but definitely learned a lot with Kevin and Ken. And I really want to go and play more with with Socket.io and Web PubSub. And also the Playwright session was amazing, very in-depth, a lot of knowledge. I am really surprised because I didn't know some of the things that they showed today. I'm really amazed at the numbers also. The 5 million downloads in a week, that's amazing. Yeah,
no, I agree with you 100%. Dina, did you happen to have a favorite session today? I know they were all incredible, but is there any that stood out for you?
The GraphQL one was pretty high on my list. I do love programming with GraphQL, but to be able to skip some of the parts that aren't necessary to bootstrap faster, I do love that. But the Socket.io one actually showed the integration with the Contoso real estate project in a way that really made the project shine for me with that integration. So I'm thrilled to get back to Contoso now.
Yeah. Sounds good. Yeah, and I agree with you both. The sessions were all amazing. The speakers were incredible. I think for me, all the topics were amazing. What really stood out was how simple Stacy and Thomas made it look. I don't know if it's that simple in reality, but from their delivery, it really looked easy to just get started with APIs and using data API builders. So I think that's a wrap for today. So I just want to share like a quick reminder that our Cloud Skills Challenge is still ongoing and it will be live until the end of next week. So a huge kudos to the 500 plus developers that have already joined this Cloud Skills Challenge and are actively learning. So join the challenge to get started with your practical exercises. And in case you're wondering what this challenge entails, well, it has a set of self-paced learning modules that have hands-on exercises. So for today and yesterday, mainly you've just been observing what our amazing speakers have been doing. But now it's time for you to go and practice. It's time for you to get your hands dirty with some code. So definitely join this challenge. Among the modules, you will learn to use GitHub Copilot with JavaScript. You will publish either an Angular, Svelte, Vue, or React application, and even APIs with Azure Static Web Apps. You'll also learn about MongoDB API with Azure Cosmos DB. You'll again get a chance to get started with cloud native apps and the containerized deployments, and of course, a great resource for you to get started with Azure OpenAI service. Now, that's just a bit of what you're going to cover, but there's a lot more that you can go in depth during this Cloud Skills Challenge. So if you've not yet done so, scan the code on your screen, access the link on the chat, and then you have the next 7 days to complete these Learn modules. And with that, I will pass it to Dina to kind of wrap it up for us today.
Awesome. Thank you for joining us today. I love the sessions on databases, sockets, and testing. The Cloud Skills Challenge is a great way to continue your learning journey on how to use JavaScript on Azure. Let's continue this conversation on the Contoso real estate discussion. The sessions are recorded and will be available on YouTube. Thank you.
Thank
Awesome.
you. Bye.
Thank you all. Bye.